Write down. Types of order of reaction. So first one is zero order reaction, first order, second order, third order, and fraction order, pseudo first order reaction. So in all this, important is only examples, right? First one, zero order reaction. Tell me, what is a zero order reaction? So let us consider a reaction. A gives rise to something product. Okay, A gives rise to product. Tell me, when A gives rise to product, let us apply the rate law. So according to rate law, what is a rate equal to? K into molar concentration of A power 0. Why it is A power 0? Zero order reaction. For all zero order reaction, the molar concentration of A should be 0. Therefore, now what is the rate equal to? K, rate constant. Now tell me, so define what is the zero order reaction. So zero order reaction is the reaction in which rate of the chemical reaction independent of concentration of reactant. It means rate is independent of the concentration of reactant, then such reactions are called what? Zero order reaction. Okay, write down. The reaction in which a rate of chemical reaction is independent of concentration of reactant. Independent of concentration of reactant called zero order reaction. The reaction in which rate of chemical reaction is independent of concentration of reactant is called zero order reaction. Okay, next slide. And take this. Consider a reaction. Consider a reaction. A gives rise to product. And take according to rate law, rate equal to K. Tell me, from this point what do you understand? Rate equal to K, it means the rate of zero order reaction is independent of, right on. Next point, the rate of zero order reaction independent of concentration of reactant. Yes or no? So rate is independent of concentration of reactant. Next point. Then what is the unit of rate constant of zero order reaction? The unit of rate constant of zero order reaction is similar to unit of rate of chemical reaction. Right, next point. The unit of rate constant of zero order reaction similar to rate of chemical reaction. That is mole per liter per second. Okay. So next is examples. So what are the example for zero order reaction. 1. Decomposition of Hi over gold surface. Decomposition of Hi, hydroiodic acid, over the gold surface. So Hi undergo decomposition to Hi, it gives us to H2 plus I2. It must be on gold surface where gold is a catalyst. Tell me, for this reaction what is the rate? Apply the rate law. Rate equal to K into Hi power 0. It is not 2, even though 2 is there, but rate is independent of concentration, no. Therefore, now this equation is called experimentally determined rate equation. Therefore, order is 0. Next, one more example. Decomposition of ammonia over molybdenum or tungsten. Take down. Decomposition of ammonia. Presence of either molybdenum catalyst or tungsten catalyst. Tell me, when ammonia undergo decomposition, so it is a reverse of manufacturing. 2 ammonia gives rise to N2 plus 3H2 over molybdenum or tungsten surface. So it is also zero order reaction. Write the rate equation for this. Rate equal to K into molar concentrations of ammonia power 0. Next, another example, decomposition of phosphine. What is a phosphine? PH3, like ammonia, phosphine. Okay, so similarly, 2 phosphine undergo decomposition, it gives rise to phosphorus and 3 hydrogen. Okay, so phosphorus usually it is a P4 molecule, no? That's what you can take a 4 molecule, it become 6, right? So this reaction also takes place usually in presence of tungsten as a catalyst. Next, photochemical, one more example is photochemical combination of chlorine and hydrogen. Photochemical combination of H2 and Cl2 chlorine. Right. So hydrogen and chlorine undergo combination reaction in presence of usually H nu. It gives us to 2HCl. So therefore, it is also example for zero order reaction. Okay. Tell me, what is the rate equation for this? Rate equal to K into H2 molar concentration power 0, Cl2 molar concentration 0. Therefore, rate equal to K. So therefore, then tell me how to remember zero order reaction in generally. Say 1, 2, 3 examples. See, first example, decomposition of Hi over gold surface and ammonia, here it is phosphine. All are decomposition. But here decomposition, they are actually heterogeneous. These reactions are called heterogeneous catalytic reaction because this is in gaseous state, it is gas and gas. But here gold is a solid. Therefore, catalyst is a different phase, reactant are different phase. That means if the reactant and product and catalyst two are different phase, then they are called what? Heterogeneous catalytic reaction we study in surface chemistry. Therefore, in generally, heterogeneous catalytic reactions and photochemical reactions are zero order reaction. So like this you can remember. Note, you can remember note. Generally, heterogeneous catalytic reactions and photochemical reactions, right? So heterogeneous catalytic reactions and photochemical reactions. Okay, so therefore heterogeneous catalytic reactions and all photochemical reactions are zero order reactions. Tell me, so what is the reason that heterolytic catalytic reactions and photochemical reactions are zero order reactions? The reason is, in heterogeneous catalytic reactions, the rate is independent of whatever you have taken reactant concentration. Here rate is depends on what? Gold surface, means catalyst, right? So because we study on gold surface, what happen in heterogeneous catalytic reactions? Reactant comes and adsorb on the surface of the catalyst. If the surface has more, if the catalyst has more surface area, there is a more adsorption, more reaction takes place, fast reaction takes place. It means the rate is depends on the surface of the catalyst but not the concentration of reactant. Similarly, in photochemical reaction also, rate does not depends on the concentration of H2 and Cl2. Rate depends on the H nu taken. Okay, we have studied H nu with more energy, more frequency, there is a rate is more. That means the rate of the chemical reaction depends on the what? Frequency of the sunlight but not the reactant concentration. That is what they are zero with respect to this. Next is first order reaction. First order reaction. Tell me, in first order reaction, consider a reaction A gives rise to product, right? Now apply the rate law. So according to rate law, if it is a first order, what is the rate equal to? Rate equal to K into A power 1. Okay, so therefore rate equal to K into A power 1, then order equal to what? 1. It means, what is the definition of first order reaction? The reaction in which a rate of the chemical reaction is directly proportional to first power of the molar concentrations of the reactant in experimentally determined rate equation. This must be a experimentally determined rate equation. Therefore, the reaction in which a rate of chemical reaction directly proportional to first power of the molar concentrations of reactant in experimentally determined rate equation is called first order reaction. Then what is second order reaction? Definition same. The reaction in which a rate of chemical reaction is directly proportional to second power of the molar concentrations of the reactant in experimentally determined rate equation. What is the third order reaction? The reaction in which a rate of chemical reaction directly proportional to third power of the molar concentrations of the reactant in experimentally determined rate equation. Then what is the fraction order? It is the reaction in which a rate of chemical reaction directly proportional to fraction power of the reactant, molar concentration reactant in experimentally determined rate equation, in even it is a pseudo first order. Then pseudo first order different. What is a pseudo first order reaction? Pseudo first order is, it is actually first order. Order is 1 but molecularity 2 or more. The reaction in which order is 1 but molecularity 2 or more, such reactions are called pseudo first order reactions. Okay, take first order reaction. The reaction in which rate of chemical reaction is directly proportional to first power of the molar concentrations of reactant first power of the molar concentrations of reactant in experimentally determined rate equation. In experimentally determined rate equation called first order reaction. So take this, consider a reaction. Consider a reaction A gives rise to product according to rate law, rate equal to K into A power 1, order is 1. So first example, decomposition of PCl5. And tell me, if the PCl5 undergo decomposition, what do you get? PCl5 gas, it gives rise to PCl3 gas plus Cl2 gas. Then write the rate law. So according to rate law, rate equal to K into molar concentrations of PCl5. So therefore it is nothing but power 1, no? Order equal to 1. Next, one more example. Decomposition of N2O5. So decomposition of N2O5. Tell me, in N2O5 decomposition, the reaction is like this. 2 N2O5 gives rise to how many NO2? This equation given in your textbook, important, many times repeated. NO2 plus O2. Then, but what is the mechanism? Mechanism is step 1. In step 1, there is a one molecule N2O5 gives rise to NO2 plus NO3. This is a slow step, RDS, rate determining step. And in second step, there is another N2O5 now combined with NO3, it form 3 NO2 plus O2. This is a fast step. Okay. So therefore, now tell me, rate law is applied to, applicable to whether slow step or fast step. So slow step RDS. Therefore, now rate is equals to K into N2O5 molar concentration power 1. Therefore, order equal to 1. Similarly, decomposition of H2O2. This was the previous question. In textbook, some examples are given. Those examples you have to by heart. Decomposition of H2O2, hydrogen peroxide. Hydrogen peroxide undergo decomposition. It is a H2O2 gives rise to H2O plus half O2. Its order equal to 1. Okay. Next, another example. Hydrolysis of acid hydrolysis of methyl acetate. Acid hydrolysis of methyl acetate. So what is the methyl acetate? CH3, C double bond O, it is CH3. Right, it is ester. Ester undergo hydrolysis in acidic medium. Hydrolysis reaction with water. It is taken excess and there is H plus. Tell me, ester undergo hydrolysis, what do you get? This bond is broken, you will get CH3, COOH plus H2O. Now tell me, is it first order or second order reaction? Apply the rate law. Okay, this is a aqueous medium, it is a water. Come on, tell me, what is the rate equal to K into? Now rate equal to K into either methyl acetate or H2O. It is only methyl acetate. methyl acetate power 1, you can take water also, but water power 0, because yes, in a chemical reaction the reactant taken in excess quantity, it does not change the rate, means order with respect to excess reactant is 0, so therefore order equal to only 1. Right, so these are the some important example for first order reaction. Okay, next is second order. Write the same definition. What is second order reaction? The reaction in which a rate of chemical reaction is directly proportional to second power of the molar concentrations of reactant in experimentally determined rate equation. The reaction in which rate of chemical reaction, the reaction in which the rate of chemical reaction directly proportional to second power of the molar concentrations of reactant, second power of the molar concentrations of reactant in experimentally determined rate equation. In experimentally determined rate equation. Let us consider a reaction. A gives rise to product. Okay, then according to rate law, a rate of chemical reaction directly proportional to what? Molar concentrations of reactant or active mass of the reactant. Therefore, what is rate equal to? K into A power 2. So then you may have doubt, here 2 is not there, no, even though you have taken 2. Let it be here 2 is not there, but it is experimentally determined rate equation, no. In experimentally it is proved that rate is directly proportional to 2 powers, means power 2 of molar concentration of reactant. That's what it is a 2, not because of here 2, not here, not written, that is different. So therefore it is a second order reaction equation. Then example. So what are the example for second order reaction? Like 1, nitrogen plus oxygen, it gives rise to 2NO, N2 gas, O2 gas. Tell me, what is the rate equal to? K into N2 molar concentration and O2 molar concentration. Next, one more example. Decomposition of HI. Decomposition of hydroiodic acid, HI. Okay, and tell me, so 2HI undergo decomposition, it gives rise to H2 plus I2. But same example you have written, zero order. But the difference is, in zero order reaction takes place there, gold surface. If you write gold surface, it becomes zero order. If you do not write any catalyst, it becomes second order. That is the difference. Therefore now here rate equal to K into HI molar concentration 2. Alkali hydrolysis of methyl acetate. Alkali hydrolysis of methyl acetate. See, we have taken, it is acid hydrolysis of methyl acetate. In acid hydrolysis, we take hydrolysis acidic medium and water will be there. But in alkali hydrolysis, this methyl acetate now reacts with dilute NaOH. Okay, we do not take water separately. We take dilute NaOH. Water in the form of NaOH is available. It is a dilute. So therefore, now tell me what it forms. Ester undergo hydrolysis, it forms carboxylic acid now. But sodium is there. Sodium acetate plus we will get methyl alcohol. Here we have written methyl alcohol. No, we did mistake here. Methyl alcohol should be there. Bond breaking, no. So methyl alcohol should come. Along with methyl alcohol, you will get sodium acetate. Now tell me, what is the rate here? Now rate equal to K into molar concentrations of methyl acetate and molar concentration of what? NaOH, both. So therefore, acid hydrolysis is a first order, alkali hydrolysis is a second order reaction. Next, third order reaction. So write the definition of third order reaction. So what is third order reaction? The reaction in which rate of chemical reaction is directly proportional to third power of the molar concentrations of reactant in experimentally determined rate equation. The reaction in which rate of chemical reaction is directly proportional to third power of the molar concentrations of reactant. Same. The reaction in which rate of chemical reaction directly proportional to third power of the molar concentrations of reactant in experimentally determined rate equation. So A gives rise to product, then rate equal to A power 3. Let's see example. NO plus O2, 2NO plus O2 gives rise to 2NO2. Tell me, order is 3. One more. 2SO2 plus O2 gives rise to 2SO3. So in this reaction also order is 3. These two same equation we have taken where? Molecularity, third molecularity. Okay, it is a third order reaction. Next is fraction order reaction. Fraction order reaction. In fraction order reaction, the rate of chemical reaction is directly proportional to fraction power of the molar concentrations of reactant in experimentally determined rate equation, right? So in our syllabus, 2 examples given. Those 2 examples are important. One, H2 plus Br2, it gives rise to 2HBr. Okay, then what is the rate? For this equation, it is observed that rate equal to K into rate is directly proportional to the one power of hydrogen is 1, that is power 1, and Br2 is power half. It is experimentally determined equation. Okay, you cannot question it. Why? New question madangilla. So therefore, new question ಮಾಡಿದ್ರೆ ಮಾಡಿ ನೋಡಿ ಅಂತ ಹೇಳ್ಸಿ, ಮಾಡಿ ನೋಡಿ ಗೊತ್ತಾಗುತ್ತೆ ಅಂತ ಹೇಳ್ತೀನಿ ನಾನು ಅಷ್ಟೇ, ನನಗೆ ಗೊತ್ತಿಲ್ಲ. 1 plus half, it is, tell me, 3/2. Okay. Next, so there is another example. CO, carbon monoxide, reacts with chlorine, it gives COCl2, it is called fuzzine. It is a poisonous gas. We'll get haloalkane, halorin topic, fuzzine. Okay, tell me, what is the rate for this reaction? Rate equal to K into, here, carbon monoxide power 1, but Cl2 power 3 by 2. So therefore, what is order? So order of reaction is, it is a 1 plus 3 by 2, that is a 5 by 2. It is a fraction power. Next is pseudo first order reactions. Pseudo first order reaction. So what is pseudo first order reaction? Here, the reaction in which order is 1, order must be 1 only. The reaction in which order of reaction is 1, but molecularity is not 1, molecularity is 2 or more, then the reaction is called pseudo first order, right? The reaction in which order is 1, the reaction in which order is 1 but molecularity is 2 or more, but the molecularity is 2 or more, called pseudo first order reactions. Pseudo first order reactions. Example 1, acid hydrolysis of methyl acetate. So acid hydrolysis of methyl acetate. Tell me, methyl acetate undergo acid hydrolysis. Already we have written this equation. Reaction with water. It is in aqueous medium. It is a liquid, and moreover water is a excess quantity. What do you get? Methyl, that is acetic acid plus methyl alcohol is the product. This is in acidic medium. Come on, tell me, what is the rate? So according to rate law, rate equal to K into molar concentrations of methyl acetate power 1, water power 0. In this reaction, what is the order? Order of reaction is 1, but molecularity 2. So we have studied molecularity is what? What is molecularity? Molecularity is nothing but the number of reacting species which take part in the RDS or which take part in the reaction in elementary state. Okay, therefore these two are the reactant, they are involving in the reaction, they take part in the reaction. Okay, but here what is order? Order is the number of reacting species which changing their concentration. See, involvement is different, changing concentration is different. Okay, involvement itself is not a changing concentration. So these two are involving in the reaction, but water do not change its concentration. That's what, with respect to water, molecularity will be there, but order is 0. So that's what, molecularity is 2, order is 1. So therefore, acid hydrolysis of methyl acetate is a pseudo first order reaction. Next, one more example. Yeah, acid hydrolysis of sucrose. We have studied in carbohydrate. It is also called inversion of cane sugar. Right, acid hydrolysis of sucrose. It is also called inversion of cane sugar. It is also example for pseudo first order reaction. How? Here sucrose undergo hydrolysis, C12H22 O11 sucrose plus water, sucrose in liquid, okay, that is in aqueous medium, it is AQ, this is a pure liquid, and moreover their water is in excess, and acidic medium, it gives C6H12O6 plus C6H12O6. One is a glucose, another one is a fructose. Now here apply the rate law, you will get rate equal to K into molar concentration of what? Sucrose, right? C12H22O11 power 1, and the molar concentration of water is 0. Therefore, order is 1, molecularity 2. It is also pseudo first order reaction. So these two examples given in textbook, you just remember those two examples enough. Okay. Okay, now let's see differences between order and molecularity. Sometimes questions are like this: which of the following true regarding order, or which of the following false regarding molecularity or regarding order? So questions can be expected like this. So that's what if you write the differences, so that all the points can be covered. Okay, right, differences between order and molecularity. Differences between order and molecularity. So take one side is order, other side molecularity. Come on, tell me. So first, what is the first difference? Definition, no? So what is the definition of order? It is what? Sum of the molar concentrations of reactant, sum of the powers of the molar concentrations of reactant in experimentally determined rate equation. That is the order. Now this side is what? The number of reacting species which take part in the reaction in elementary state or RDS is called what? Molecularity. Okay, so that is a definition you can write. Next, second difference. It is a experimental value. It is theoretical value. Next, it may be whole number or fraction or even 0, even negative or positive. So order may be negative, order may be positive, it may be whole number, it may be fraction, it may be 0. This is always whole number and it is always positive. Molecularity never become negative. Molecularity is always positive. Next, any other difference? It depends, yes, it depends on reaction condition because it is experimental value, no. So since it is an experimental value, depends on experimental condition. Therefore, it depends on reaction condition. Depends on reaction conditions. What about it? It is independent of reaction conditions, does not depend. Any other differences? All point covered, no? Okay. Now next we have integrated rate equation for zero order and first order reaction. Write down integrated rate equation for zero order reaction. See, in our syllabus we have only zero order, first order reaction, that integrated equation. Okay. Tell me, we have let us derive easily. First tell me what is zero order reaction? The reaction in which rate of the chemical reaction is independent of what? A rate of chemical reaction independent of the concentration of reactant is called zero order reaction. For zero order reaction, suppose A gives rise to product P, then rate equal to K into, it is R power 0 now. If I take R is a concentration of reactant, R power 0. Okay, so write down, write the definition of first. Write the definition of zero order reaction. ಅದು ಹೇಳ್ಬೇಕಾ ಬರೀರಿ. The reaction in which rate of chemical reaction, the reaction in which rate of chemical reaction independent of, the reaction in which a rate of chemical reaction independent of initial concentration of, no, independent of concentration of reactant, independent of concentration of reactant, called zero order reaction, called zero order reaction. Right on. Consider a reaction, consider a reaction. A gives rise to product. Consider reaction A gives rise to product. Tell me, according to rate law, according to rate law, can we write rate is equals to K into R molar concentration of reactant power 0, where R is a molar concentration of reactant, R is a reactant, P is a product, no? That. Next, but we also know that rate equal to what? Minus dr by dt, no? Instantaneous rate minus dr by dt. We have studied average rate, instantaneous rate. So therefore, rate also equal to minus dr by dt. Then equalize equation 1 and 2. Okay. Then tell me, then if you equalize the equation 1 and 2, what do you get? Minus dr by dt equal to K into R power 0. But we know that R power 0 is 1. Okay. Since R power 0 is 1, so you can take, it is a dr, I'll take this minus, you can bring here, no? It means you can make it minus like that. So dr equal to, and minus K will be there, this is 1, so bring d here, t here, dt. Okay. So therefore dr equal to minus K into dt. Okay. Take this is equation 3. Then tell me, for equation 3, what to do? Integration. Right. For integrating the equation 3. So integration of dr equal to, it's since it is a constant, no, there is no integration for constant, and integration of dt. Okay. Then Yeah, for integration of dr equal to what? R, no. R and minus k, integration of dt is t plus take I, where I is a integration constant. In some book given C also. We can take I, where I equal to integration constant. Board exam ಅಲ್ಲಿ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್. Zero order, first order ಎರಡರಲ್ಲಿ ಒಂದು ಕೊಡ್ತಾರೆ. Okay, now suppose tell me here I equal to, ಇಲ್ಲಿ ನೋಡಿ, we want actually I equal to we want. Therefore what I do is, if t equal to 0, it means what? Before starting the reaction, no. If the t equal to 0 before starting the reaction, then what is R equal to? So R equal to, R become R naught, because t equal to 0, it becomes 0. Then R before starting the reaction, R is 0. Then substitute t equal to 0, R equal to R naught. Then what do you get? R naught equal to minus k into 0 plus I. It means what do you get? I equal to R naught. Okay. So therefore, now this R naught value substitute in equation 3, equation 4. So therefore, substitute R naught in equation 4. Then what do you get? R equal to minus KT plus R naught. This is one important equation for graph. Equation 5. Graph can be plotted on this equation. Okay. Next. Now tell me, I want KT equal to. So transfer KT here. Minus KT become plus KT. Plus KT equal to, let it be R naught as it is, R naught minus R. Right? So this is another equation for graph. Graph can be plotted on this equation also. Next is, but actually we want K. So K equal to what? R naught minus R by T. Okay. Important for problem. Therefore, for zero order reaction, here onwards we take this equation. K equal to R naught minus R by T. Where what is the K equal to? Rate constant of what? Rate constant of zero order reaction. Okay. Then where R naught equal to initial concentration of reactant, and R equal to concentration of reactant only, but what time? After time t. So it is a concentration of reactant after time t. Of course t is a time, it is in it may be in time in where? Seconds or minutes, depends on the question. Okay, so this is a integrated rate equation for zero order reaction. K equal to R naught minus R by T. Okay, but actually we want other forms of equation. Can you write any other forms of this? Sometime they give question like this: which of the following is a rate equation? Which of the following is a equation is related to zero order reaction? So we may not expect always this equation. This equation can be, modified in other way. So therefore, let's see other forms of zero order, other forms of integrated rate equation for zero order reaction. Is there any other forms, or you can change it? No. Now tell me, you can change like this. This is 1 K equal to R naught minus R by T, no? Okay, fine. But do you know R naught is the initial concentration of reactant, it can be taken as a small a. So small a is a initial concentration of reactant. Okay, next, so where R naught become a, because a is a what? Initial concentration of reactant. Okay, next is I'll take X is a concentration of product. Concentration of product is a X. Then tell me, if I take X is a concentration of product, then what is R actually? Where, what is R here? R equal to, it is a concentration of reactant only after time t. It means R is a concentration of reactant after time t. But actually we have concentration of product. Then how do you get concentration of reactant after time t? Concentration of reactant after time nothing but initial concentration of reactant minus concentration of product, no? Initial concentration of reactant minus concentration of product, which is nothing but what? Concentration of reactant after time t. It means, so this R is nothing but initial concentration minus, then what has to subtract? Concentration of product. Therefore R is nothing but, no, A not is not required, A minus X. So therefore now substitute in this equation. I want equation 2. So K equal to, tell me, R naught let it be A minus R equal to A minus X by T. Then simplify equation, will get equation 2, that only. Okay, so K equal to what? It is a X by, no, Y minus, man, X by T, right? Therefore where X equal to concentration of product, it is another form of zero order reaction. Okay, then you can also write another form also, third one. It is R naught minus R, no? Therefore I can also write K equal to C naught minus CT. C naught is the initial concentration, CT is a concentration of reactant after time t divided by T. So this can also be written. Okay, so those are the 3 different forms of integrated rate equation for zero order reaction. Now let's see graph. So what is the graphical representation of zero order reaction? On based on the graph, from this topic question can be expected. E topically graph mele questions bandide previously. So let's see graphical representation. Graphical representation of zero order reaction. So you can plot the graph on equation 5. You can also plot the graph on equation 6 also, even 7 also. Okay, let's see one by one. First one, tell me, R equal to minus KT plus R naught. Tell me, a graph is plotted between, it is a R, that is Y equal to, this is a mx plus c. Yes or no? That means a graph is plotted between what? R versus time t. So therefore, then tell me, what is the graph? So it is concentration on y axis, on x axis time t. You see the slope. In graph we need to check the slope only. Questions, 99% questions based on slope only. Slope value kotto, what is the k value they may expect, that's it. Not only here, in almost all the graphs slope is important. So slope is negative or positive either? Slope is negative, intercept is there, therefore this is the graph. And here, what is the slope equal to? Minus In question they will give the slope value. Okay, a graph is plotted between R versus T for zero order reaction. The slope value equal to minus 3 into 10 power minus 2. So and so the value give. By giving the slope value, they may expect a K value. So that it is nothing but slope value equal to K value. Right. So that means you can calculate the rate constant of zero order reaction directly. Next, second one. Second equation is this. A graph is also plotted between KT on KT equal to, it is a R naught minus R. Okay. Now here, can I take like this? It is a graph is on plotted between, it is y equal to, okay, this is mx plus c no. Now tell me, a graph is plotted between, on y axis you can take it is a r naught minus r on y axis, t on x axis. Now what is the intercept is 0. When intercept is 0, it passed from origin, and what is the slope is? K. Next, third one. A graph is plotted for seventh equation also, where seventh equation is K equal to, it is R naught minus R by T. Come on, tell me. Now it is nothing but you will get same equation. We wanted to plot the graph this in between these two only. Okay. So nothing but it is, you have to bring KT here, KT equal to R naught minus R. You will get same equation. Okay. 1, 2. Right. So this is the graphical representation of zero order reaction. Next, half-life period of zero order reaction. Half-life period. Half-life period. Tell me. So what is the definition of half-life period? It is the time taken to convert half of the concentration of reactant into product. Right. So the time taken to convert the half of the concentration of reactant into product is called half-life period. Okay. The time taken to convert half of the concentration of reactant into product called half-life period. Okay. Now tell me, what is the rate equation for the integrated equation for zero order reaction? K equal to, you should remember it now, R naught minus R by T. You have to memorize it. So R naught minus R by T. So okay, now I want, if T equal to T half, tell me, if the time equal to half-life period, then what is R equal to? R equal to R naught by 2, because the time taken to convert half of the concentration of reactant into product. No, that means when T equal to T half, then R must be equal to R naught by 2. Sorry. Right? Then substitute in the above equation. Then what is K equal to? K equal to R naught, let it be as it is. Then R become R naught by 2, then divided by, it is T become what? T half. So therefore R minus R naught by 2 will get R naught by 2. Then what is the K equal to? K equal to R naught divided by 2 into T half. Actually we want T half equal to R naught by 2K. Important for zero order reaction. Now tell me, for zero order reaction T half, what is the relation between T half and initial concentration? See, don't confuse. For zero order reaction, rate is independent of concentration. That's all right. Rate is independent of concentration of reactant, but T half is directly proportional to initial concentration. Right? Therefore, write one important point. In zero order reaction, T half is directly proportional to initial concentration of reactant. T half is directly proportional to initial concentration of reactant. Okay, now see, questions are like this here. Since here T half is directly proportional to initial concentration, question is like this: for a hypothetical reaction, A gives rise to B. It's a T half equal to 50 minutes. The concentration is 2. Okay, concentration is 2. When the concentration is doubled, T half also doubled. What is the order of reaction? Zero order tane. See, for a hypothetical reaction, A gives rise to B. If the concentration of reactant is doubled, half-life period also doubled. Order of reaction is 0. Because for zero order reaction only, it is directly, T half is directly proportional to initial concentration. Right? Initial concentration is doubled, T half become doubled. That is zero order reaction. Okay. So next is characteristics of zero order reaction. Characteristics of zero order reaction. Okay, now we'll write all here in short form. Right. So idhar mele questions can expect ಮಾಡಬಹುದು. The same thing whatever we have studied now will represent here in a sequence. And tell me, first one, in the characteristics of zero order reaction, first point is rate is independent of concentration or dependent on concentration? Okay, first point, rate is independent of concentration of reactant. That means, so rate is equals to K into R power 0. Now here let me draw one graph. A graph is plotted between rate versus concentration. Tell me, ಏನು ಬರ್ಬೋದು? Is it rate is depends on concentration? No. Since rate is independent, tell me. Parallel, very good. Since rate is independent of concentration, you will get a straight line which is parallel to x-axis. Okay, that's the first characteristic. The same thing we have been studying, no? That's it. Next, 2. Then what is the unit of rate constant of zero order reaction? The unit of rate constant of zero order reaction similar to rate of the reaction, that is mole per liter per second. Right. The unit of rate constant. The unit of rate constant K is similar to rate of chemical reaction. Similar to the rate of chemical reaction, that is mole per liter per second. Next 3. Tell me, third one is integrated rate equation. Write directly. So what is the integrated rate equation for zero order reaction? Already baridivi, no sir, bariri. K equal to R naught minus R. Tell me, among R naught, R which is greater? R naught. Very good. By T. Ashta nimpidiyala. Ade khush padbekasthe. R naught minus R by T. It is an integrated rate equation for zero order reaction. Okay. Idr mele ondi graph bardiralla, drop madidra graph. Already madidralla. Okay. Next, fourth one. What is the T half? So T half of zero order reaction, R naught by 2K. Okay. So this can also be written like this. T 50% is equals to R naught by 2K. Outane. Now tell me, fifth point. So here also you can draw the one, draw the graph. Tell me, this T half, no. Take, it is on y axis. Okay, y equal to mx plus c, no. On x axis you take R naught. In birthday. On y axis T half is taken. On x axis, okay, tell me, R naught. R naught taken. So anyhow c equal to 0, no. It is a straight line passing through the origin. And what is the slope equal to? Yeah, the slope equal to 1 by 2K is important. That is a T half of zero order reaction, not T50. Next is, I want T100. Fifth point is T100%. What is the meaning of T100? The time taken to complete the zero order reaction. So what is the time taken to complete the zero order reaction? Tell me. That is a T100 equal to time taken to complete the zero order reaction. See, T half equal to T50 equal to R naught by 2K, no? Then what is that? T100 becomes? It is a 2 into R naught by 2K. So it means nothing but T100% equal to R naught by K. Okay, here there are three important equations. Relations are important here. One, T50% already we have. Did we know it? Tell me, T50 equal to what? R naught by 2K. Okay, this is all right. Okay, this can also be written T50 or T half equal to T50 equal to T half barkoli, and I want T75% equal to what? And T100 equal to written. T100 is what? No. R, no. 2 into T half. Very boda? Yeah. Yes. See, T100 equal to R naught by 2K, no? But T50 equal to what? R naught by 2K there. Here is K. Yes or no? So therefore, so T100 equal to 2 into T half. Then T75% reaction equal to 3 by 2 means 1.5. 1.5 into T half. This is nothing but 1 T half. So T 50% equal to 1 T half, T 75% equal to 1.5 T half, then T 100 equal to 2 T half. Can be written. Okay. Next, what is the relation between rate and time for zero order reaction? Is there any relation between rate and time for zero order reaction? Sixth point is relation between rate and time. Is it rate of chemical reaction changes with time or does not changes with time? Changes. If it changes, how? As the time is increases, like 0, 1, 2, 3, 4, 5 minutes, time is rate is say if it is not depends on concentration of reactant, how can depends on time it is, right? No, as the reaction proceeds, concentration of reactant increases. No, as the time proceeds, like 5 minutes, 10 minutes, 20 minutes, concentration of reactant increases, product decreases. Therefore, concentration of reactant product changes time when time increases, so that rate is changes. So as rate is independent of concentration, there is no relation with concentration, no relation with time also, right? Initially what is the rate is there, the final also same rate. So therefore rate is independent of time. So this is also important. For zero order reaction, rate independent of time. So therefore if you plot the graph between rate versus time, since it is independent, which gives a straight line which is parallel to x-axis. Okay. Then last characteristic is, what is the rate of reaction for gaseous phase reaction? Yesterday somebody asked me for gaseous state reaction. So this topic related to chemical equilibrium in that concept only, particularly in gaseous phase. If you understand gaseous phase reaction here, I hope we can do it in chemical equilibrium, same related questions easily. Okay. So therefore now seventh point is, write down, if the reaction or when the reactant, one second, when reactant and product are in gaseous phase, when the reactant and product are in gaseous phase, the partial pressure of reactant and product is measured. The partial pressure of reactant and products are measured instead of what? Molar concentrations. Instead of molar concentrations. Okay. So majority students get confused here only. But ಸ್ವಲ್ಪ difficulty level question ಕೊಡಬೇಕಂದ್ರೆ ಈ ಟಾಪಿಕ್ ಅಲ್ಲಿ gaseous state ಅಲ್ಲೇ ಕೊಡ್ತಾರೆ. This is sure. Okay, that's what. Listen carefully. If you understand this, first order it will be same. Now, for example, let us take A gives rise to product something, product B anಕೊಳ್ಳಿ. It is in gaseous state, it is also in gaseous state, both are in gaseous state. Okay. Now tell me, if it is aqueous solution, what is the rate constant? Zero order, K equal to R naught minus R divided by T, or else K equal to A minus X by T can be taken, no? Where X equal to what? Concentration of product. Okay. So therefore now let us take, for example, initial ಇನಿಷಿಯಲ್ ಪ್ರೆಷರ್, ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದರೆ ಇನ್ನೊಂದ್ಸರಿ ಕೇಳಿ, ಬಟ್ ಲಿಸನ್ ಕೇರ್ಫುಲಿ. Initial pressure of A, I'll take P naught. Okay, concentration is R naught, pressure is P naught, initial pressure. Then what is the initial pressure of B? 0, because before starting the reaction there is no product, pressure is 0. Next, then now we want pressure at time T. Okay, that is called even equilibrium pressure. Partial pressure at or after time t, not at, after time t. So after time t, the pressure we want, let me take, we don't know, it is x atm. If I take x atm is the pressure of the product. Okay, then tell me what is the pressure of the reactant? Initially P naught, no, minus, and moreover it is a 1 mole, it is 1 mole, right? So since it is a 1 mole, therefore 1 mole converted to 1 mole, then P naught converted to x, then x will be reduced here. P naught minus x is what? Partial pressure of the reactant partial pressure after time t. Okay, therefore now what is the K equal to? So you can take K equal to R naught minus R. And tell me, if you take R naught minus R, what it become? R naught is P naught minus P naught minus x by t, then K equal to x by t. Where what is x equal to? No, partial pressure, no. X equal to partial pressure of product at what time? After time period t. Okay, this is one equation. Sometime they may give the total pressure, fine. If can you tell me what is the total pressure of the reaction? This I want P total. P total equal to P naught minus x, that is the pressure of partial pressure of the reactant, and partial pressure of the product. So what do you get? So P total equal to P naught. Yes or no? So therefore P total equals to P naught. In place of P naught, can you get P total? P total again it get cancelled, you get same only. Okay, for this equation you will get same. Next, let us take for example, okay, a zero order reaction is A plus B, not take A only, A gives rise to B plus 2C. Idre a zero order reaction is A gives rise to B plus 2C. Now let the initial pressure P naught, this is 0 0. Next, at equilibrium, pressure at equilibrium, let me take, it is 1 mole, no, it is 1 mole, no, I will take x. If it is x atm, what it become? 2x atm. ಅವಾಗ ಇದೇನಾಗುತ್ತೆ? P naught minus x ಆಗುತ್ತೆ, 3x ಅಲ್ಲ. ಅದೇ ಇಂಪಾರ್ಟೆಂಟ್ ನೋಡಿ, ಬಿಕಾಸ್ ನೋಡಿ 1 mole ತಾನೆ, 1 mole ಕನ್ವರ್ಟ್ ಇಂಟು 1 mole, 1 mole ಟೇಕನ್ x ಆದರೆ ಎಷ್ಟು ಕಡಿಮೆ ಆಗುತ್ತೆ? x ಕಡಿಮೆ ಆಗುತ್ತೆ ಅದರಲ್ಲಿ. ಅರ್ಥ ಆಯ್ತಾ? ದಿಸ್ ಈಸ್ 1 mole ತಾನೆ, 1 mole gives 1 mole 2 mole all right, but you compare like this, 1 mole gives 1 mole. Okay, 1 mole of reactant gives 1 mole of B, 1 mole of B taken x atm, therefore the what is the pressure is reduces x atm only. Don't see that x plus 2x 3x ಕಮ್ಮಿ ಆಗುತ್ತೆ ಅಂತ, no. So therefore it become P naught minus x, but actually I want P total. Tell me, P total equal to what? P naught x plus x, which is equals to P naught plus 2x. One second. ಎಕ್ಸ್ ಪ್ಲಸ್ 2x ಆದರೆ 3x ಆಗುತ್ತೆ, 3x ಅಂದರೆ 2x ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ ಎ ಪಿ ಟೋಟಲ್. ಓಕೆ, ನೌ ಇನ್ ದಿಸ್ ರಿಯಾಕ್ಷನ್, ಫಾರ್ ದಿಸ್ ರಿಯಾಕ್ಷನ್ now tell me what is the k equal to. K equal to it is P naught minus P by or R naught minus R by T. No, let it be. Now tell me K equal to R naught. What is R naught? P naught minus R equal to what? R equal to initial concentration minus minus what? Product concentration or pressure also. What is the initial? P naught. What is the no initial is P naught. P naught minus what is the product concentration? Or else you do one thing, take this x by t. No, but simple ಆಗಿ ಮಾಡ್ಬೋದು. X by t, where x equal to what? Product concentration means product pressure. What is the product pressure here? X plus 2x, it is a 3x by t. Yes or no? ಅದೇ ಬರುತ್ತೆ ನಿಮ್ಮ ಇದು ತೊಗೊಂಡು ಮಾಡಿದ್ರು ಅದೇ ಬರುತ್ತೆ. ಆರ್ ನಾಟ್ ತೊಗೊಂಡು ಆರ್ ನಾಟ್ ಮ್ಯಾಟ್ಸ್ ತೊಗೊಂಡು ಕ್ಯಾನ್ಸಲ್ ಆಗಿ ಇದೇ ಬರುತ್ತೆ. ಸೊ ದೇರ್ ಫಾರ್ ಇನ್ ದಿಸ್ ವಿ ಕ್ಯಾನ್ ಡೂ ದ ಪ್ರೆಷರ್ ರಿಲೇಟೆಡ್ ಕ್ವಶನ್ಸ್. ಓಕೆ, ಟೇಕ್ ಡೌನ್.